See, same diagram I'm drawing something like this. Magnetic field is something like, if you look from this side, then how the magnetic field is coming out. Okay, na? Magnetic field is coming out, and how the disk will appear. Disk will appear. Disk, if you see from this side, how the disk will appear. Disk will appear like something this. This is the disk. Am I right? Disk will appear of length 2r, and width is, thickness is d. Yeah, thickness is d here. Here thickness is d, and this length is 2r. So disk appears as 2r length, and thickness is d. Okay, now if you take a 1 rupee or 2 rupee coin and you see from one side, then it will be like something like a straight line. I mean, what do you say, the rectangle strip. Okay, so disk will appear in this way. Now let us say that as you are releasing the disk, then what will happen? Disk is falling down. Let us say for some time. So we don't know whether it is really fall down or go up. Okay, na? Let us say it is falling down. As it is falling down because of gravity, then what happens? It will achieve some velocity. So disk will get some velocity v downward, and mg force also will act downward. I think no need to say this part. So let us say that disk is moving with velocity at some instant. So I don't know that velocity is constant or increasing or decreasing. We have to identify now. So v, it is moving with v at this instant. I will solve for that particular instant only. So if it is coming down with velocity v, conducting disk only, there is a conducting disk. Okay, so conducting disk is, or conductor is moving inside the magnetic field, then there will be some induced EMF. Am I right or not? So now that EMF will be perpendicular to velocity, or else you can check like this. You take any electron is getting the velocity v downward, then v bar cross b bar will be leftward. That means electron will experience the force rightward. Then this surface will be negatively charged, and this surface will be positively charged. So which we call it as potential difference, induced EMF. Potential difference between those two surfaces. So what is the induced EMF? I can write down. Induced EMF across the disk. First of all, see, whatever known things are there, no, we write down. We dump all known ideas to the question. Then only it will solve. Okay. So induced EMF across the disk is, what I can write down? I can write down that, let us say delta V, which is equal to BV into length across which the charges are accumulated, BVD. Actually BVL, no? So magnetic field and velocity perpendicular to each other. Length, thickness is perpendicular to the velocity, or else length across which charges are accumulated. So I can write down BVD. Okay. But this velocity may be increasing, or may be decreasing, or may be constant also. So we don't know that. Suppose that as it is moving downward, let us say velocity is increasing. Again assumption. Let us say velocity is increasing. As velocity increases, more charge flow, more electron flow will be there. So that will create some current in the disk. As the disk is falling down, velocity is increasing. As velocity is increasing, potential difference has to increase. As velocity increases, potential difference will increase. As potential difference is increasing, okay, potential difference increase. To increase the potential difference, then electrons, more number of electrons has to move. So it has to create the more charge. So that means there will be a current. As electrons are moving towards right, there will be a current towards left. Okay, na? Clear this part? Yes. There will be current from the leftward direction. As there is a current in the leftward sense, and magnetic field is, how the magnetic field is? Magnetic field is out of the board, then L bar cross B bar. This is L bar. Now I am calculating the force acting on the disk due to magnetic field. So current direction will be the L bar and magnetic field is out of the board. So L bar cross B bar will be upward. So the force will be, this is the force due to magnetic field, magnetic field on the disk. So here what is the assumption? Assumption is velocity is increasing, let us say. Assumption is velocity is increasing as it is falling under gravity. Clear? There is a current. Now how to find out the current value? To know the current value, we can find out the charges. Let us say this is plus Q and this is minus Q. So now I can take this one as a what? This one as a capacitor. So what is the area? Circular area. One side circular area, other side is obviously circular one only. You can take this side is negative charge. This side is the negative charge accumulated. On the other side it is positive charge accumulated. So closely spaced two discs you can take. Two surface you can take it as two discs. So you can take it as a capacitor. Then what is the capacitance value is equal to? Capacitance value is epsilon naught A pi r square by distance between them is thickness D. Okay, na? This is one plate with positive charge, this is the other plate with negative charge. What is the distance between the two plates? D. And what is the radius of the plate is R. So area will become the pi r square, area of the plate. So it's a capacitor. Then what is the charge value? Charge on any face I can write down C into delta V. So the charge value I can write down epsilon naught pi r square by D into delta V. What is the delta V is equal to BV into D. So D cancel out. What is the charge value is equal to epsilon naught BV pi r square. You can write down anyway. This is the charge value. Then what is the current value I can write down? Current value I can write down dq by dt. If I am writing dq by dt, epsilon naught B into now dV by dt into pi r square. Because velocity is variable, no? I told that velocity is increasing. That's why I have taken the positive only. This one, positive number. So this is the current. If this is the current, how the force is acting? Force value. Now this is the magnetic field. This is the current. Current is flowing across the length of D. Current flows across the length of D. Then what is the force acting due to magnetic field? The force value is equal to I into L into B or L cross B bar. I into L bar cross B bar. L bar cross B bar is upward direction. So L and B perpendicular to each other. So I can write down the force value is equal to current into length is nothing but D into B. So the force value is equal, current value is we have. So epsilon naught B square pi r square into D, which is dV by dt is nothing but force is epsilon naught B square pi r square into D into A acceleration. So as it is falling down, and velocity is increasing, let us say that acceleration also downward. Then what is the equation I can write down? Mg is acting downward, force is acting upward. Then equation can be written as on the disk mg is acting downward and force is acting upward, and we are taking that it is accelerating downward. Velocity is increasing in downward sense, so accelerating also downward. That's the assumption. Then what is the net force I can write down? Net force is equal to mg minus F is equal to ma. So mg minus F value. What is the F value? This is the F value. Epsilon naught B square pi r square D into A. Epsilon naught B square pi r square D into acceleration is equal to ma. So finally mg is equal to m plus epsilon naught B square pi r square D into acceleration. So acceleration value is equal to, see, I got final acceleration value positive, that means my assumption is correct. If I am getting the acceleration negative, then my assumptions are wrong. So reverse.